Okay, welcome everybody. I'll begin by reminding you that the homework 7 assignment should be uploaded to Blackboard before class on Monday. And as I was observing earlier, it's been a while since we had a quiz, and you will have just submitted an assignment. So Monday will be kind of ripe territory for having a brief assessment activity at the beginning of our class. So that is Monday. And then just to make these periodic reminders about the project, right now you should be gathering information related to the type of job you want to have when you graduate, some salary data from a variety of sources. Don't just rely on one person who's working in your field and the salary that they've got. Maybe triangulate that with, if you find a website that says what the typical salary is for that kind of job, and then maybe an actual openings on monster.com or maybe the government USA Jobs website. So if you have several different data sources for a reasonable starting salary, then that would be a good starting point for part 1, where you're addressing the income. And remember that on the project you're supposed to have the income increasing over the course of your career. So it's not realistic to assume that you'll be making the same thing after 40 years of experience that you're making as a fresh graduate. So there's going to be some salary increases, partly having to do with cost of living adjustments, but then also related to the fact that you'll know more and be more effective and more useful as a productive employee, so they'll probably pay you more because of that expertise, and along the way you may be promoted as well. So you'll have to kind of work through those assumptions and document it in section 1 of your report. But if you get an early start now, and I've had a few students stop by during my office hours and ask questions, that makes it clear that they're thinking it over and they're not waiting to the last minute. So hopefully everybody else follows suit. Any questions on these announcements? Okay. In class on Wednesday we talked about internal rate of return. And today's class we're going to focus on external rate of return. But before we do, just as a refresher activity, let's work through an internal rate of return example problem. So if you haven't already, start up the Excel on your computer. And here in the problem statement it's describing to us that we have an equipment purchase that we're going to do now, and it includes some sort of ongoing annual cost, and then each year we're going to get revenue, and then we dispose of the equipment at the end of 6 years, and so we have a salvage value. So you'll have to translate this statement into a cash flow table in Excel, and what we're looking for the internal rate of return is use the goal-seek method. Don't just use the equals IRR method. I mean, you can use that to check, but use the goal-seek method that our objective is that the sum of the present worths should be equal to 0 by changing some interest rate. So you'll set it up the same way that you have before, where you've got I in one cell and then an amount in the other, and then you've got year, amount, PV of amount, and so you've got year 0, year 1, year 2, and so on and so forth. For amount, put the net amount. So if any given year there's both an outflow and an inflow, find the net resulting amount, and then find the present value of the amount at this guess interest rate. So maybe just as a starting point, you can begin with 1% interest. And then down here at the bottom, you're going to have the sum of all of these present values of amounts. And you're going to goal seek so that the sum is 0 by changing some interest rate. And that which brings balance between the inflows and the outflows, that's the internal rate of return. So I'll give you a few moments to work on this one. I'll also demonstrate on the screen after I've given you some time to get ahead of me. So in the internal rate of return, we want the sum of the present values to be 0 by changing the interest rate. We're looking for what interest rate brings balance between the inflows and the outflows. That is the definition of internal rate of return. So we do here data, what if analysis, goal seek, and our objective is set this to a value of 0 by changing the interest rate. We turn it loose, and what it finds is that the internal rate of return is 25.05%. And we can double check that with the IRR function, which does basically everything that we just did manually. It does it in an automated way with equals IRR. And we do the entire cash flow sequence of the original amounts, not the PV of the amounts, of the input actual cash flow diagram. And it says here 25, if I expand a little bit, 25.05%, so the same. That's the internal rate of return, and we can use it for initial screening. Here in the example it says, what if our MAR was 20%? Should we purchase this equipment if our minimum acceptable rate of return is 20%? Well, yeah. Since the rate of return is going to be 25% on this investment and our minimum is 20, then the decision criteria says accept. So this is an acceptable alternative.
Your cash flow only be 6 years?
Oh, yeah, I guess it should, right? Let's see. 6 years. Thank you for noticing that. Boy, I really got out of hand there. All right, so... All right. That's what happens when you put examples together at the last minute. All right, so this is the one where we have the 115,000. Okay. And let's make sure that the sum just includes... Okay. Let's go seek it again. All right, 22%. Is that what you got?
Yeah.
Well, good thing it's still an acceptable alternative, even if it's only generating revenue for 6 years instead of 8. Thanks for catching that mistake. Any questions on the internal rate of return? Yes?
So you want the MAR to be below the internal rate of return then?
Well, the definition of MAR is minimum acceptable rate of return. So what that tells us is that the minimum return we can accept is 20%, and this is greater than that minimum, and so our decision is yes, we could accept this alternative because its rate of return is above the MAR.
Okay.
Now, the limitation of the internal rate of return is it assumes that what you're going to do is all of that revenue you get is going to be reinvested into that project or into a project that earns 22% interest. In other words, it's assuming that your profits are going to compound. So it assumes compound interest. But that's not always the case. We don't always have opportunities to reinvest our money. And one example is in the case of art. You can make an investment, but when you sell the piece of art, you can't reinvest back into that same piece of art because someone else just bought it. Now, here's a painting. I don't particularly like it. I think it's kind of boring. It's the sort of thing my grandma would maybe have on the wall in her bathroom or something. But somebody liked it because Gauguin's When Will You Marry sold for $300 million in February 2015. So we're all in the wrong line of work. Here we are learning engineering, and what you really needed to do is paint bathroom art. You get $300 million. But whoever bought that, originally, back in 1893, they paid $750 for it when it was first sold. Now, $750 back then was a lot of money. In today's terms, that's about $20,000. But still, going from 20,000 to 300 million, that person did a pretty good investment. But the issue is we couldn't calculate the internal rate of return of that investment because the person, when they sold it for 300 million, cannot reinvest their profits into the same painting. So the point is this is an illustration of one type of investment where we need a different type of tool to analyze how good it is. We need external rate of return, where the profits aren't being reinvested in the same original thing. So just to summarize, IRR can tell you whether a project is acceptable. It can't be used for comparing alternatives, and that proof is still coming, but the warning is that you can use it for initial screening. It will tell you which of the alternatives is potentially acceptable, but it's not necessarily true that the project with the highest IRR is the best one. There are counterexamples to that. The internal rate of return assumes reinvestment into the same project. And so a savings account, you can reinvest your interest there. You can keep the money in the bank, and then next month your profit will be on your original deposit and the interest from the previous month. And so the interest continues to compound in the case of a savings account. But there are some projects where the money that's generated by that project has to be reinvested into some other opportunity. And so buying a rare painting, the profits can't go back into the same painting. And so external rate of return is a way that we can analyze those kinds of projects where there's going to be more than one interest rate. There's the interest rate of how much profit is being generated by the original investment, and then the profits that are generated are put into another account that earns a different interest rate. So what external rate of return is it's kind of like a weighted average interest rate, where you have two different interest rates that are being applied. The rate at which profits were generated, and then the rate that compounding occurred on the profits. Now it uses the external reinvestment interest rate, and in our book that variable is assigned I sub I. The external reinvestment interest rate is that account where you're putting the profits that got generated. So the person who sold the painting, where did they put that money? Did it go into a savings account? Did they buy bonds with it? If we want to know their overall rate of return, we have to track not only how much did the original investment generate, but then where they put the profits and at what rate did those profits compound. So I sub I is where it's reinvested. Now here's the method I'm going to demonstrate with the cash flow diagram in a moment. Here's our procedure in text. And I'd say that this procedure that I'm about to show you there's two or three things that is the most misunderstood concept of the whole course, and this is one of them. So if you can figure this out, if you can stay focused for the next 15 minutes, then you will have understood one of the top three most misunderstood things of the entire semester. So I really encourage you to focus all your attention on understanding this method. So the first thing you do is you take the net outflows and you discount them to the present at I sub I. Now what interest rate is that? That's the external reinvestment rate. So that secondary account where the profits are being put, you're discounting all outflows to the present. And when it says net outflows, there might be a year where there's both an inflow and an outflow. So you need to find the net difference between the two, and in any given year, if it's an outflow, take it to the present. The inflows, meaning revenue, instead of being discounted to the present, it gets compounded to the future. So you take the inflows to the future, and again, you're using this external rate. Now, what ERR, the external rate of return, is, it's assigned the variable I prime. It's the interest rate that brings economic equivalence between the present value of the outflows and the future value of the inflows. So let me show you graphically what the procedure is. So you'll have some cash flow diagram like this, and you'll take all of the outflows to times 0, and you'll take the inflows to the present. You notice how this year there's both an outflow and an inflow? Before you move the money, you need to find the net amount. And so this isn't going to go to the present. But this arrow, a little bit lower than we see it because we subtract out the costs. So the net revenue in this case would be compounded to the future, and we do that at I sub I, which is the external reinvestment rate. Any questions so far in the first part of the procedure? Yes.
The external reinvestment rate is just the rate of like the account that they would put their revenue in, right?
That's right. And the external reinvestment rate is typically given in a problem statement. So I'd say, all of the profits that you're generating with your business are going to go into account Z, which pays 5%. That's the external account that all the profits go into. And then what you're solving for is the overall external rate of return. Now, the sad thing, external reinvestment rate has the same abbreviation as external rate of return. And I worry that maybe that's part of what gets people confused, is ERR is not the same thing as external rate of return. So here, external reinvestment rate is the given, and what you're solving for will be the external rate of return, which this is a part of. Okay, so the net amounts, and now the third part of this is that you take this future amount, which is the revenues, take it to the present, and you're solving for an unknown interest rate. You're looking for what interest rate would make the height of this arrow, meaning the absolute value of the amount, the same as the absolute value of the expenses. So you want the expenses and the revenues to be equal through some unknown interest rate that you're going to be solving for. So I prime is the external rate of return. So this is the graphical approach. External rate of return is the one that makes the present worth of the future revenues equal to the present worth of the expenses. It's complicated, but I've developed a template file that I hope will help you see the method. That template file is and the method itself is based on, here's the formula for it. It's showing like which factors we're using. So you're going to take the expenses to the present, all of the expenses to the present, after the revenues have also been taken originally to the future and then back to the present again. So that procedure is built into the template file that you can find if you go to our course page. At the bottom, there's this external rate of return student start file. If you download that and open it, we're going to do our in-class exercise inside of this template file today. And I've set things up in this template file to mimic the procedure that we follow here, where we are going to have time, a time axis, a reverse time axis, because we're taking some amounts to the future. So this is what we always do when we're taking amounts to the future. We'll have the overall cash flow amount, and then we split it up into the outflows and the inflows, because the outflows go to the present, the inflows go to the future, and then we find the sum of the outflows, the sum of the inflows, and then we're going to discount the sum of the inflows to the present at some unknown interest rate. So you have to start with the guess. Here it says external rate of return. Initially start with a guess. So for today's activity, let's start with a guess of, say, 1%. And then we're going to keep changing this over and over until this and that are equal. Okay, let me go to the problem statement and I'll hand out the paper. Here's our cash flow diagram. We're going to try and find the external rate of return for this statement. So remember, if you get this, then you've figured out one of the hardest things from the whole semester. So it's really worth getting today, not just watching me do it, but actually figuring it out and understanding it. Pays big dividends.
Does that make sense? So what you guys are saying is I have to take this value to the future next, and then I take this value to the present. Alright. So I have to do the PV of that in relation to that.
goal C, you set this 7 equals the value of this 7 by changing this.
Would it be the absolute value of that cell, though?
Yeah, I just made these possible.
And then we have
Okay, so let me just summarize what we've done. We've got some business opportunity. We're spending $25,000 to buy this company. And when we do, it gives us a certain amount of revenue each year, except for in year 3, we have some, it must be a refurbishment or a maintenance cost or an overhaul or something where the net expenses are greater than the revenue in that year. So we split up the outflows and the inflows, take all of the outflows individually to the present, and found the sum of the present value of the outflows. Did a similar thing with the inflows, except for that in the FV function we're using this reverse time column because we're taking it to year 7, not to year 0. So you'll notice here in the FV function I'm using years until for the number of periods. Now all of these I've used the given external reinvestment rate for the discounting and the compounding. And so it's 25,929 at the present, 37,032 at the future. And so remember in that graphical summary of the method I said you aggregate all of the outflows to time 0, aggregate all of the inflows to the future. Now the next part is we just start with a guess value of the external rate of return. So maybe it's 1%. And then I'm going to do the PV function on this. The method says to find the present value of the sum of the future values of the inflows. That's a really long sentence, but you're finding the PV of this sum of the future value of the inflows. Okay, so I'll do that with equals PV at this guess rate, which I'm going to change around. It's occurring over 7 years to take it from where it's at now back to the present. So I'll just type in the number 7 and then skip over the payment field because it's a single lump sum future value of that. So at 1%, it's not yet equal. At 2%, I'm getting closer. At 3%, even closer. But rather than keep manually iterating, I'll do data, what if analysis, goal seek, and my goal is to set this, to value 25,928.60 by changing this guess external rate of return and let it go. And so it finds that if the rate of return is 5.22%, then the present value of the sum of the future value of the inflows is equal to the present value of the outflows. So what does this all mean, though? It means that the weighted average rate of return between the rate at which the cash was being generated and then where you put the profits, the weighted average is 5.22%. Now just take as an illustration, what if we did the IRR on this cash flow? Like what if we could have reinvested the profits? What would our rate of return be then? So just to show you, if you do the IRR on the cash flow, the internal rate of return is 7.49%. But in this project, we can't reinvest it in that same thing. Whatever profits we're getting, each year we put it into this low-paying bank account. This low-paying bank account is only giving us 2.5%. And so the external rate of return, you'll notice, is in between the two because it's a weighted average. It's saying you're getting some of your profits from the rate at which the revenues are being generated, but then you have to take into account the compounding. And the compounding effect, since the compounding is happening at a lower interest rate, it brings the weighted average down to some amount in between the external reinvestment rate and what the rate of return would have been if all of the profits could be internally reinvested. But they weren't, so we will ignore that. They weren't reinvested internally, they were reinvested externally at 2.5%. And so it brings the weighted average of the rate of return down to 5.22%. So there it is, one of the most complicated methods of the semester. And if you practice this a couple times, it'll never confuse you. But if the only other time you do it is once for the homework and once for the exam, when you do it on the exam, you know, those 2 times may not have been enough. So my suggestion is maybe save this file and then try and solve the in-class exercise another time and see if you got it right. Because this is a really important one. It's one of the most realistic analysis methods we've got, because very few projects can be internally reinvested. Most real-world projects have to be externally reinvested. So this is a really important one. So I'll remind you that your homework assignment is due on Monday. We'll have a quiz Monday at the beginning of class. Have a good weekend.